Hi guys, there is a couple of questions from section 4.5. First one is, this is section 4.5, number 29. So this is what we call the exponential equation, and they want us to solve it and also round the answer to 3 decimal places. So the equation goes like this: 3 times 2 raised to the power of x minus 2 plus 1 equals 100. Okay, so we want to solve for x. So obviously, we need to bring the x down from the exponent. So one way to do that is to apply the log to both sides. There is actually a property, if you look in your textbook on bottom of page 461, that says if you have 2 equal expressions, if you take the log actually in any base, log in any base of both sides, you still have equality. Now, natural log is one that a lot of people use. You can take ln from section 4.3, as you know, ln. It means natural log, log base e, or you can take any base, log in any base of both sides. But first, we need to, of course, remove the 3 and 1. That way we can have just this expression, the exponential expression, and then we take the log of both sides to remove the exponent, okay? So first remove the 1 by subtracting. So now we have 3 times 2 to the power of x minus 2 equals to 99. And then we divide by 3 to remove the 3 in front. So now we have 2 to the power of x minus 2 equals to 33. Okay? So now to remove the x minus 2, we can actually, because the base is 2, you can actually take log base 2 of this expression, and the 2's cancel. There, as you remember, there's a property that says when the base of the log is the same as base of the number, they cancel. Or you can take natural log of both sides. Either way, it will be the same thing. Okay, I'm going to go ahead and actually take natural log, maybe a little easier. So we're going to take natural log of both sides. The reason why we do that, because remember the power property from section 4.3, is anytime you have log of something to a power, the power can go to the front. So that really turned into x minus 2 times natural log of 2 equals to natural log of 33. Okay, so now we're going to remove the natural log of 2 so we can isolate the x term. So we'll divide both sides by natural log of 2, or also known as ln of 2. So now those cancel. I'm going to go ahead and move it up here. Okay, so from there, once the natural log of 2 is canceled, we have x minus 2 left on the left-hand side, and then, of course, natural log of 33 over natural log of 2. And the last step is to add the 2 so we can remove the net minus 2. So we add 2 to both sides. And so finally, we have x equals to natural log of 33 over natural log of 2 and plus 2. Okay, so if you use your calculator, remember you have a ln button for ln, natural log. If you use your calculator, divide natural log of 33 by natural log of 2 and add it to 2. You should get value approximately, I think they want 3 decimal places. So 7.044, I believe, is what you should get as you round your answer. Okay, but this is the exact answer, and that will be the approximation for the solution for this equation. Okay, let me see if I can do also the one more, and then I'll probably make another video for a couple of more questions on logarithmic. These are the exponential equation, but the student also has some question about the logarithmic. So let me do the next one, which is, I believe, 31. Same section, 4.5, number 31. So on 31, we have 2 times 1.05 raised to the power of x equals plus 3 equals to 10. Okay, so once again, we asked to solve this. So the first thing we're going to do again, try to isolate the exponential expression, which is just 1.05 to x. So first we remove the 3 by subtracting. So now we have 2 times 1.05 raised to the x equals to 7. And then we'll divide by 2 again to remove the 2 in front. which says 1.05 raised to the x equals to, I'm going to go ahead and round that, put the decimal for that, 3.5, I believe, is same thing as 7/2. So now we're going to go ahead and take again natural log of both sides, so we can bring the x down. So we take natural log of 1.05 raised to the x equals to natural log of 3.5. So you can always take natural log of two equal expression. If you take the log, natural log, or log in any base, you still have equality, okay? So that's what allows us to take natural. The reason why we do natural log, take natural log, so we can bring the x down. So now as the x come down by the power property, as you remember from section 4.3, the power property said the power can always becomes your coefficient. It will be, x times, and then natural log of 1.05 equals to natural log of 3.5, okay? So of course, the last step we need to divide both sides by natural log of 1.05 so we can isolate the x. I'm going to go and show that up here. So from here, once we divide both sides by natural log of 1.05, so now what you have, x equals natural log of 3.5 divided by natural log of 1.05. Again, don't forget you do have a natural log button on your calculators. So if you plug that in, your approximation would be 25. So your x is approximately 25.677. So to 3 decimal places, your solution would be 25.677. Okay, I hope that helps. I'm going to make another video in a minute on the two problems, 45 and 47, which are from the same section, except those are the logarithmic equation, where these were the exponential equation. Okay, hope that helps.